Hi everyone, welcome back to my channel Solve It with Arash. In today's video, we are going to solve an interesting problem about the intersection of two square root functions, and we'll be using function transformations along with graphing the two functions. It's going to be a lot of fun. Before we dive in, if you enjoy math content and you want to see more, please give this video a thumbs up and subscribe to my channel Solve It with Arash. Your support really helps the channel grow. Now, with no further ado, let's jump in. All right, here is the question. For real numbers x and k, for which values of k will the graphs of the functions f at x equals negative square root of x plus 2 and g at x equals square root of x minus 1 plus k intersect? To solve this question, let's first talk about the graphs of each of these two functions. F at x equals negative square root of x plus 2 is a transformation of the base function square root of x. The negative coefficient will make a reflection in the x-axis, and plus 2 under the square root will shift the graph 2 units towards the left. Because x plus 2 has to be greater than equal 0, so x is greater than equal negative 2, and therefore x equals negative 2 is the start point of the graph. Now we have enough information to sketch the graph. This is x-axis and this is y-axis. The graph is reflected in the x-axis and shifted 2 units to the left, and the start point is at negative 2. So this is how the graph looks like for f at x. Now let's talk about g at x, and I'm going to change color to dark blue. G at x equals the square root of x minus 1 plus k. There's no reflection in the x or y axis because there's no negative coefficient. X minus 1, it will be a 1 unit shift towards right, since x has to be greater than equal 1 to maintain a non-negative value under the square root. So the start point is at x equals 1. And if we don't consider k for now, just ignore k value for now, the graph of g at x will look like this. That's square root of x minus 1 without having any k value. Now, positive k values will shift the graph upward and negative values will move it down. In order to make a point of intersection between the two graphs, we need to move this graph down. And once we move it down this direction, the first point when the two intersect will be at this point where x is 1, because on this graph x equals 1 gives the lowest point on the graph. The lowest point will be the first point to intersect with the other graph, with the graph of f at x. Therefore, the point of intersection has a x value of 1. So now we know the x coordinate of point of intersection is 1. Point of intersection between two graphs is a point where the two graphs have the same x and y values. Now we know the x value. The y value also will be the same for f and g. Therefore, if I find f at 1, that should equal to g at 1. We don't know the k value for g, so we cannot evaluate g for now, but we can do that for f. F at 1 equals negative square root of 1 plus 2, which equals negative square root of 3. This has to be equal to g at 1. G at 1 equals square root of 1 minus 1 plus k, which equals k, and we just mentioned that it has to be equal f at 1. So k equals negative square root of 3. Now we have a value for k, but is it the only answer to this question? So let's check out the graphs again. When k is negative square root of 3, g at x will be here. And that's the first time the two graphs have a point of intersection. But if I move it further down, they will still maintain a point of intersection. It's just going to change location. But since the blue graph is increasing always and the red one is decreasing always, it will definitely have a point of intersection again, but not in the same place. It's going to move towards right. By that, now we can say for any k value less than negative square root of 3, the two graphs will have a point of intersection. So the final answer to this question is k values less than equal negative square root of 3. Okay, I hope you enjoyed this question and the way we solved it. If you have any questions, feel free to leave it in the comment, and I hope to see you next time. Take care.